Hello and welcome to this quick run through on Crimson 3.2. My name's Andy Lester and I'm one of the engineers at Red Lion. So with Crimson 3.2 we're able to program the latest in the range of Crimson devices from Red Lion, the DA70 and the DA50. Other devices are going to be added to it and we'll have a look at those probably at some time in the future. So getting right into it, what I'm hoping to be able to show you is the emulation that we've got on board, protocol conversion, data logging and the web display, just to show you how quick and easy it is to set all those things up. So first of all, with emulation, what we can see here is a button with the emulator in Crimson 3.2, and this allows you to open up a virtual screen within the environment that you're using it on, say for instance your laptop. This means you can make up a project within Crimson and you can hit the download button and it will download to an emulator which will appear on your laptop, and you'll be able to press buttons on the screen and check the logic of your project and see how it looks. And given that the software is free and easy to download from Red Lion, you can actually download and test a project without putting out any financial risk effectively. So moving on from there then, so how do we use Red Lion as a quick protocol converter then? First thing we can do is I'll show you this device configuration. This is effectively all our router settings in the device, so it basically acts as quite a well-functioning router on the device, so we can set up our IP addresses and what have you in this area. Once we've done that, we can go down to communications and we can choose a protocol that we might want to talk. So let's just take a few of the big guys out there. Let's say for example Allen Bradley. We can talk to an SLC. In this case I'm using DF1, and if I just rename that guy as SLC just so we can see it later on, we would put in the appropriate IP address, whatever suits, and we can have multiple SLCs underneath this protocol if we wanted to. We can have, you know, as many as our bandwidth allows. The next thing we can do is add another protocol, and this time maybe I'll go down to something else that's quite common, maybe Siemens or Mitsubishi. If I add maybe an FX or something in here. And lastly, I'll do a Siemens. Okay, and I'll put a Siemens S7 300 400. That also works for the 12 and 1500s. So if I quickly put down there an S7 or something in there. We could also put Modbus if you liked, but we can have up to 10 different protocols running under this system on the Ethernet side. Obviously on serial you can only run one protocol at a time, depending whether, you know, so that's your limit there. Let's just show you how quick and easy it is to say take some registers out of a Siemens and put it into say an FX or an S7. So what we'll do is I'll add a block. Let's say we're looking at some counters on there. So we go to the Siemens, you'll see it lays out the data in the Siemens way, sorry, in this case the Allen Bradley way of laying out the data. If I go to the counters, let's get the accumulation, because that's typical of them. Let's say start at register count 100. I'll locate that, and then maybe a block size of 3. And I can then just quickly just pass that block across out to let's say a Mitsubishi, and maybe onto a D register in the Mitsubishi. And let's go to registers block, I don't know, 900 over the side. And how many blocks? Well, let's do all 4 of them. I'll locate that. And it's as simple as that. So we can take those accumulations from the Allen Bradley in this case, and we can pass them over to the Mitsubishi. And it's that simple to do. If we take the Mitsubishi now, I'll do the same sort of thing, just so in case you missed it. I'll add a block. And here I'll do pick a block size. Let's go for D registers because they're pretty much common. I'll start at D0. I'll OK that. I'll make a block size of say 3. Ooh. So we've got 3 D registers there, 0, 1 and 2. And I can map them out to whatever I like. Let's go to the Siemens now, just to make it a bit different. And let's go to a data block on the Siemens. And where there, as you can see, we can choose our data block and the addresses within it. We'll do byte as byte. We'll OK that. Number of registers, let's do all 3 of them. So it's as easy as that to basically do any kind of protocol conversion. More importantly than that, if we want to actually go in and pull out tags individually, we can do that too. In Red Lion we have 3 different ways of referring to these tags. So numeric is a regular register, normally contains a number, A flag will always be an individual bit, an on or an off, and a string tag is as it sounds, it just contains a string. The reason we use this naming structure, if you like, is because we deal with over 300 protocols and everybody calls things different things. So if I take a numeric out of here, what I'll call it, this is tag 1, let's just call it reg_1, and I can take a register, and I've told it about our SLC and FX and S7 earlier on. If I click on the SLC, it comes up, as you can see, the Allen Bradley way of laying out the data. We could then go in and quickly point to any one of those devices. If I go back and we'll choose something else, maybe an FX, we'll take a D register and whichever register you like. So now the unit will just go out and poll register 99 on the FX, and it's very simple to bring that data tag in. We can repeat this process, and in fact we can actually have lots of these registers. Say this is just register 1, we can have a few of those, and as you can see, as I'm adding the duplicates, it actually increases over here the register address location. So let me just do that again, 1, 2, 3, and we can see this register keeps totting up for each one we go to. So it's a quick and easy way to map a lot of registers across. Now, I'm not getting too much into the weeds on this. One of the other things I want to show you is data logging. Let's go quickly down to our data logger down here. We can create a data log very simply. Whatever we put in the contents here, we can just drag and drop our various registers that we're interested in. And when we set up the data log, we can set up in one of two ways. We can set up as a triggered snapshot, which will occur an event that we put in this trigger down here, or a continuous sample, which is the most common. We can put any amount of seconds we like in there, as regular updates as we like, but the default is 60, and there's 1440 minutes in a day. It'll write a new file at the end of the day, and after 7 files, it'll rewrite over the first one, so you don't run out of data. And you can change all these numbers to your heart's content to suit your application. You can get the measurements down to once a second without any problem at all. So setting up the data log really is a walk in the park. The other things we can do is set up the web server. So setting up a web server on this device is very simple. By default, it's actually enabled. If we were to create a display page on here, for example, that would be displayed on our web page, and we could even actually enable remote control here, so you could press buttons on your display page, which would then go and be as if you're pressing it on a local screen, if you like. So things I can do on this screen, just to quickly show you, this acts like a very simple HMI. You can bring in blocks and devices, and we can have those devices interact with the tags that we've generated before. So I can have this block fill up from the bottom, for example, in accordance with register 1. We can overwrite the min and max, which is the 0 or 100 or whatever we put in there, and that will basically display things. We also have a library of symbols that we can use. If I go and pick something random, let's say maybe boilers, they're always interesting. Oh, let's change the resolution of the screen for me, just as I did that. So let's pick in a boiler, and what we're seeing there is a boiler on the screen, which, you know, you can basically draw whatever pictures and things you like and put manipulatable devices on there. You can show temperatures. I could grab one of those data tags and display that on the screen quite easily. These sort of things are easy to do. Anyone who's programmed in HMI will recognize most of this. So these screens can then obviously be put onto the web server straight through our simple system of and making sure that checkbox is checked, and it's already done for you. You can turn it off obviously by unchecking that. You can also make custom websites, which are really simple and quick websites where we just put the tags that we want to be able to manipulate, and these will be basically displayed as they are there, with the option to allow editing or not. It's up to you whether you check that or not in this area here. And this lets you change tags just for testing if you like, and it creates a web page where you can do that. Other things we can do is we can pull in data from an SQL database, and that's again very easy to do. Just click on the device here, we'll add a query in there, we give it the name of the column it's looking for, we tell it what kind of data's in there, and also more importantly, how many rows do we want to take, and where do we want those data to go. So I've got a row here, I could click it out to one of my tags that I've got before, or I could send it into a number of other places. But let's just go to these tags for now. And I could just load that data in. On the press of a button, I could load all the data from the SQL database into these tags, and that's great for recipes, that sort of situation. Lastly, what we've got is something here called control. You don't have to go for control, but it's available to you if need be. What this enables you to do is actually write ladder programs within this device. So if I convert this over to a ladder diagram, and anyone who's used to programming ladder logic will actually recognize most of these symbols across the top here. So we can add various devices in ladder logic, and we can link these to our tags, our data tags that we have. So it's there if in case you know how to program in ladder logic and you want to make something nice and quick and simple. It's all there available to you. If you want to program in a C-like structure, we have an option for programming in a C-like manner here. So there's a lot you can do with these devices. Going back to the tags, I mean, I could talk forever on this, but if we look quickly at, say, for example, the formats, we could do a quick scaling in these devices. We could, I'll do a quick scaling here now. If I go to integer, we might do 0 to, let's say we have a register value of 32767. We might want to display that 0 to 100 for the human operator, because it makes more sense to him in degrees. And it's as simple as that, which is much quicker than doing it, for example, in ladder logic, being able to convert the integers straight away. So there's a lot we can do in Crimson, and hopefully I haven't taken too much of your time, so there we go. Thanks very much. Bye-bye.